Uh, Class, are you seeing my notes? Class?
Yes, doctor.
Okay, let me continue. Okay.
Doctor,
Yes.
doctor, just
Okay.
now the MTBE's full form is methyl tertiary butyl E stands for what, doctor?
Ether.
Ethyl,
Ether. Methyl tertiary
ethyl.
butyl ether. Ether.
Ah,
ETHAR.
okay, okay, doctor.
Okay. That
Thanks,
is
doctor.
additive to increase the octane number. Okay.
Hmm.
Okay. So next, that is the feedstock. See here are the some feedstock properties of FCC. Specific gravity, this is just for your reference, no need to memorize. Specific gravity, 15 over 4. I think you already know why it is 15 and 4. 15, that is the density of that crude of that stock, like and 4 meaning that reference that here is a water temperature is 4 degrees. That is why always you see in some reference book specific gravity bracket they are maintaining 20 over 4, meaning that that the that the density of that substance calculated at 20 degrees centigrade and reference temperature at 4 degrees centigrade. Here 15 meaning that the density of that substance calculated at 15 degrees centigrade. API, you already know, API stands for American Petroleum Institute. Based on that, desulfurized vacuum gas well, meaning that VGO, vacuum gas well stands for VGO abbreviation. So around 26, this one is bit higher, around 27. These are the some fractions are given. Here, one thing, these are the sulfur, nitrogen, all the impurities content. Yes, see the here should be lower and lower, should be very low. Here, one thing, one properties you might don't know what that stands. That is Conradson carbon residue. Class, please, class, note down that that is abbreviation. That is CCR, Conradson carbon residue, CCR. Actually, this is one kind of laboratory test by which we can determine the coke forming tendency of any well. Okay, class, do you understand what is the meaning of CCR? Class,
Yes, doctor.
CCR stands for Conradson carbon residue. Actually, this is the, by knowing CCR value, we can understand that uh, that is the weight percentage of the, in that weight percentage that it started, that feedstock started to form coke, petroleum coke. Okay, coke forming tendency. CCR, that is the value by which we can determine the coke forming tendency of feedstock. That is the calling Conradson carbon residue. Is it clear, class, to you?
Yes, doctor.
Okay, okay. So this is the feedstock properties. Then this is the product properties. As you know, that product from FCC, we are getting the LPG, mainly gasoline. See, the gasoline yield is until 60% gasoline. Gasoline is main product from the FCC, gasoline. And you know that gasoline is high value product. So, but vacuum residue or VGO or residue from atmosphere, that is a very low product. Bitumen and pitch is very low. Gasoline, yes, very high. So from FCC, Mainly we are getting gasoline, which yield percentage until 60%. In addition with that, also we can produce LPG and around 20%, and some other product like light crude oil or heavy crude oil. Light crude oil, that is the LCO or HCO. LCO, that can be from there we can get the jet fuel or some other fuel like kerosene, diesel also. That is from that we can produce. And also from the FCC unit we can produce coke, which is not recommended, but produce coke, that is coke which we have to do the combustion in regenerator. Due to coke, actually the catalyst become deactivated. Now the main thing, whatever I told initially, that here is term that is calling fluidization, fluidized catalytic cracking. Now we will know what is the meaning of fluidization. The difference between other cracking unit in fluidized cracking unit, that in this unit catalyst in fluidized condition. What is meaning that? Just imagine if you put any solid particle and if any fluid pass through that solid particles, if the velocity is lower, the particles will remain stationary. Am I right, class? You understand this? Hello, class?
Yes, doctor.
Just imagine that if packed bed catalyst, packed bed, meaning that stationary, if fluid passes through that packed bed, if velocity is lower, definitely the particles will not move. But if you increase the velocity, if you increase the velocity, then the pressure drop also will be increased. If you increase the velocity, pressure drop will be increased. And in that, after certain time, when the velocity you start increase, when it reaches such condition, when the pressure drop times cross-sectional area, when it is equal to gravitational force, meaning that we can avoid the gravitational force by applying the velocity and pressure, then when the velocity when the pressure drop times the area equal gravitational velocity of that particles, when that become equal, then particles will start to move. That is calling minimum fluidization velocity. If you increase further velocity, then there will be occur some fluidization, some slugging, and if you increase further velocity, meaning that the particles will be, in turbulent mode, it will be start to move. That is calling pneumatic transport. So here see the models of fluidization. If we, here is very important, questions may come out like that, please, what do you understand by fluidization, or explain the mode of fluidization? Such type of questions may come in the test or in the exam. So modes of fluidization, if here is like that, this is the y-axis, that is the partial pressure loss, x-axis, that is the velocity. See here, if we increase the velocity, pressure loss will be increased. In this time, until this point, actually no movement. But when it reach here, then when this pressure loss times cross-sectional area of that equal to gravitational force of that particle, then particle will start to this type this condition calling that minimum fluidization. Initially, this is here packed bed condition, meaning that here velocity is lower. Here minimum fluidization. In minimum fluidization mode, pressure loss remain unchanged. If we increase further velocity, then it started to bubbling, meaning that inside the bed there is some bubbles will occur. This is calling bubbling fluidization. This is minimum fluidization. This is low velocity, no fluidization. Here packed bed. Here minimum fluidization, bubbling fluidization. After that, slagging, meaning that some bubbling and some pneumatic transport is here, meaning that the bed of the catalyst start to expand. And here, when the high velocity, then bubbling, the bubbles and the slug will disappear. Here is we can say that this is a turbulent occur, meaning that normally in the regenerator, catalyst regenerator, the catalyst become in turbulent mode, so that the combustion will be very high, uniform. All the catalyst particle will be uniformly get the heated and will remove the coke. So this is again I'm telling that in catalytic cracking units such as fluidized catalytic cracking, the catalyst become in fluidized condition, meaning that these are the catalyst particle. In between of that, the fluid, meaning that here the vacuum gas oil will passes through that. Residence time is very low. Is it clear, class, the models of fluidization?
Yes.
Class, are you hearing me?
Yes, doctor.
Models of fluidization, is it clear so far?
Okay, doctor.
Fluidization, right? Meaning that fluid velocity, as I told, that in cracking unit, the catalyst must be movement, no stationary, should be in movement condition, and velocity will be such conditions so that it can avoid the gravitational force, so that particle will be in movement. So in catalyst regenerator, why it should be movement? Because we have to combust the coke to get the uniform the particle should be uniformly heated, so that will be remove the catalyst. But see here in the fixed bed condition, normally in fluidized catalytic cracking, we will not use this type of configuration. We will use like this, starting from minimum fluidization to the pneumatic transport, like that. Fluidized. That is why it is calling fluidized catalytic cracking. Next, today we will go. This is just to inform you that in fluidized catalytic cracking, there is initially occur the primary reactions. This is just for your information. No need to memorize. Just I will show these slides that primary reactions where doing the cracking the vacuum gas well. It is doing the initial cracking, that is calling primary cracking, and we will get the gasoline and light cycle well in LCO. But in FCC, another reaction also going, that is calling secondary reactions. Actually, secondary reactions we have to avoid, but we cannot avoid fully. In secondary reaction, due to secondary reaction, when the hydrogen transfer reaction occurs, due to that, gasoline yield will be lower and lower, and it will create another cycloaddition reactor, that is which is for due to cyclization forming the it will form the coke. But actually, the desired reaction to be occur in the FCC, that is primary cracking. But secondary cracking or secondary reactions also is occurring. So let me show just what is primary reaction. See here, as we know that feedstock of the fluidized catalytic cracking, that is the heavy hydrocarbon. See, this is the paraffin, C8 octane, C8H octane. But in front of octane, there is a letter N, meaning that N number of octane, meaning that very high hydrocarbon molecular weight of NCH is very high, more than 200, 300, something like that. So this hydrocarbon, meaning that higher hydrocarbon, we know that occurs in catalytic cracking, the breakdown the catalyst. So it produced this thing olefin. It produced, this is olefin, because here is the see the double bond. So here produced olefin. So from higher paraffin or paraffinic hydrocarbon, we produced olefin. This is calling primary cracking. In other primary cracking also, see this primary olefin, whatever produced from the higher hydrocarbon, also maybe this is, see the very long chain, then it divided into two parts. See here, 1, 2, 3, 4, 5, 6, 7. C7H14 is, it break down here, C1, 2, 3, 4. C4H8, see here, 3 plus 1, 5 plus 3. C here, C7H14 break down into two olefins, here C4H8 and C3H6. This is the primary reaction occur. So also in primary reactions also alkyl aromatics, see here the alkyl aromatics produced benzene ring and the C2H4, that is ethane, ENE. So alkyl aromatics produce the aromatics plus ethane. These are the primary reactions. The secondary reactions, as I told, that secondary reactions we have to avoid, because due to secondary reactions, the hydrogen transform reactions occurring and gasoline reaction or yield become lower and lower. But unfortunately, this reaction we cannot avoid. So this is occurring from second. This is, see the hydrogen transformation occur here. No isomers, but here is isomerization is occur. So from secondary carbonium ion, it produces the tertiary carbonium ion, and after that followed by cyclization, meaning that these are the coke, whatever this is undesired product, whatever we don't would like to produce, but we cannot avoid to form the codols form. Actually, due to secondary reactions, first produce the hydrogen transformation, followed by cyclization and produce the coke. Secondary reactions we cannot avoid in the FCC unit is occurring, but advisable to run to get the maximum product by primary reactions, because it produces the olefin, the desired product. Okay, this is just whatever the reactions, no need to full memorized. As I told, that just for your reference I'm showing you. Here, catalyst, yes, this is important, you have to know. Why? Because in FCC, catalyst plays a very important role. And as I told, that normally in FCC, catalyst uses like a zeolite based catalyst. Zeolite class, hello class, dear students.
Yes, doctor.
I get notification that might be after 10 minutes again might be stopped. So I will give you again link and you have to come back again because I'm getting notifications that within 10 minutes it will stop.
Okay, doctor.
Okay, let me continue. In catalyst, FCC catalyst, we are using zeolite based catalyst, and catalyst particle size should be around 75 micrometer and surface area 800 meter square per gram. See the high, very high surface area, meaning that in catalytic, fluidized catalytic cracking, catalyst should be very active with high surface area. In fluidized catalyst, there uses added some matrix also. Matrix such as filler, then glue, and some additives to increase the catalyst activeness. So these are the metrics. So questions may also come out that write down the FCC catalyst and explain what are the metrics and why uses in the catalyst. So three types of metrics uses in the fluidized catalytic cracking. One is binder, such as glue. Binding, actually, this is in to provide the cohesion of the zeolite particles, because zeolite is the main catalyst. In between the zeolite particles, if you want to increase the cohesion, we are using binder like a glue to increase the cohesion. Another matrix uses that is calling filler. Filler, actually, that is the low cost material such as kaolin. This is like a clay type of filler. This is uses to make up the body of the catalyst, to uniform, to get the, if any catalyst, because normally zeolite is very, particles are very, it cannot, to make the body uses some filler so that the shape of the catalyst body become very smooth. And lastly, the matrix added, that is additives, uses such a very small amount of metal so that we can promote the combustion of carbon dioxide to carbon monoxide to carbon dioxide. Because why actually we have to do the combustion? Combustion we have to do in the catalyst regenerator to combust the coke, whatever produced on the catalyst itself. Because as I informed, that on the catalyst surface, coke can be deposited, or some metals also can be deposited. So in FCC unit, catalyst continuously regenerating. Actually, regeneration occurs due to combustion of coke. We have to combust the coke, unwanted particles. How we do the combustion? As you know, to provide air. By providing air, heated air, we will combust the unwanted materials such as coke from the catalyst, and the catalyst will become regenerate. To increase the combustion rate of carbon monoxide to carbon dioxide, we use additives. So, if questions may come about FCC catalyst or about metrics, you have to write down this and explain whatever just now we have learned. And as I initially told also, that in FCC catalyst, now research going on to find out the suitable catalyst. Mainly the zeolite particles must be, but some, some additives, filler, binder are added. Actually, the target objective to find out the catalyst to minimize the coke formation and get the conversion of gasoline. That is the case. Recently, Mobil, American company Mobil, ExxonMobil, they have invented one catalyst named ZSM 5. ZSM stand for zeolite, Soconi. M stands for mobile. Zeolite, Soconi, mobile. 5 catalysts. 5, that is their trade, their registered number. So ZSM, this is the modified catalyst based on zeolite, but modified catalyst. It is the actually now all the FCC unit they are using the ZSM catalyst. Zeolite, Soconi, mobile. You can Google it also. ZSM. Please go, later after the class you Google it about. You can know more about ZSM catalyst. ZSM stands for zeolite, Soconi. M, there is the company name, mobile. So they invented this catalyst, and it is very selectivity and yield and conversion of gasoline of the gas oil to gasoline is high. Now I will introduce you about the configuration. As I told initially today, beginning of my class, that in FCC unit there is a 2 sections. One is FCCR, meaning fluidized catalytic cracking reactor. This is the reactor, and catalyst regenerator, that is the CR. This is calling FCCR, and this is CR. Here, I think you can answer my questions also, that here configuration, that is calling side by side. See here, catalyst followed by reactor. Now, see here, difference between reactor and here a regenerator. Here there is one long tube. This long tube, actually this is calling riser. In regenerator, there is no such tube. On the top of the reactor, this arrangement, it is calling cyclone, hydrocyclone. On top of the reactor also there is a hydrocyclone. Hydrocyclone actually to separate solid particles from the reactor products or flue gas. Here actually hydrocyclone, here from the bottom there is a solid particles are accumulating, and on the top we get the product like gaseous product. Here in the riser, actually these are the riser, the FCCR. From the bottom, feed, you know, that is the vacuum gas well. Feed with lift media. Lift media is a steam, because as you know that through the riser, the catalyst must be, you know, in fluidized condition, not packed fluidized. So higher velocity, higher pneumatic pressure should be here. So feed with catalyst, feed with media entering on the from the bottom, and from the bottom also adding spent from the bottom regenerated class catalyst are adding. So here feed regenerated catalyst with lift media increase. So here in this riser, this long tube, the feed and catalyst residence time is very low, 2 to 10 seconds. Remember these things. The residence time in FCCR is very low. Then the cracking occur, meaning high hydrocarbon become low, and here in the cyclone, the particles, solid particles become bottom and go back again the spent catalyst to here. See, from the bottom spent catalyst to here. Here doing the regeneration by using air. Why air? Because you have to do the combustion. To